Hey everybody! This video will cover the topic Combining Functions Advanced. Now, for these topics we have two functions. These ones are called f and g, and they're defined as f of x equals the square root of 4x plus 3, g of x equals negative x plus 2. We're asked to find f times g and f plus g, then give their domains using interval notation. So we need to, before we go over this topic, we need to talk about how combining functions affects domains of those functions. So if we're given the functions and we're given that f plus g of x is f of x plus g of x, f minus g is the function subtracted, f times g is the functions multiplied, and f divided by g is the two separate functions divided. However, the only difference is the domains of the functions is the intersection of the domains of the individual functions. Now, that's not the union, okay? That's the intersection. So, if we were to draw what the intersection looks like, if we have one domain and another domain, okay, it's where they intersect or where they're in common. All right. Now, the only difference is for f over g, or f divided by g, we further restrict the domain to exclude x values for which the denominator is equal to 0. Because again, the denominator can't be equal to 0 or we're dividing by 0, and that's not something that we can do mathematically. Not mathematically sound. Okay? So remember this picture for intersection as we go on to discuss a little more about that. So here we have a function g and we have a function o, and we're asked to find the domain of g plus o. Now remember, the domain of g plus o is the intersection of the domain of g and the domain of o. And that looks like this. Because even though this green function goes from 1 to 9, the orange function only goes from 2 to 13. So they both have outputs at 2, from 2 to 9. Okay? So from 2 to 9 is our domain of our addition function. So that's what it means by intersection of functions. Let's take a look at these functions. F of x equals square root of 4x plus 3 and g of x equals negative x plus 2. And let's talk about the domain of these functions first. Well, this function f when we find the domain of this function, we say that the inside of the square root needs to be more than 0, right? Because we can't take the square root of a negative number and get a real number out. So what we do is we solve, we subtract 3, divide by 4, and we get x is greater than or equal to negative 3/4. So in interval notation, I'm going to write that in interval notation on this side. That's going to be negative 3/4 to infinity is the domain of f of x. Okay? Now the domain of g of x, well, that's just all real numbers. Right? So if g of x is all real numbers, there's my g of x domain, and f of x is just a little portion of a smaller portion, I should say, of those real numbers. The intersection, if I could draw that right, is going to be everything in the blue, right? Because all of these numbers in the blue are inside of the real numbers, right? So our domain is going to be the domain of f. Okay, so I should say the domain when we're combining the functions is going to be the domain of f. So f times g of x, all we do is we take f, square root of 4x plus 3, we multiply it by g, negative x plus 2, and we're done. We could multiply this negative x plus 3 through and get negative x, square root of 4x plus 3, plus 2, square root of 4x plus 3. Okay, but that is f times g, and the domain is the intersection of f and g, which is negative 3/4 infinity. Now f plus g of x equals square root of 4x plus 3 plus negative x plus 2. I'm squishing it a little bit there. Or we could rewrite it as negative x plus square root of 4x plus 3 plus 2. Or any arrangement of that. And the domain, again, is the intersection of those two functions. So that is combining functions advanced. But actually, first I do want to go over one problem where we're dealing with f divided by g, okay? Because there's one little extra tidbit we need to know about that. So now we have our function f and g. The domain for f is all real numbers, okay? The domain for g is when we have to consider when x plus 4, excuse me, this is not working great, x plus 4 is greater than or equal to 0. Or where x is greater than or equal to negative 4, I get that from subtracting from both sides. But what does f divided by g look like? It looks like 2x minus 3 over the square root of x plus 4. What do we know about the bottom of a fraction? A function with a fraction and a variable on the bottom, on a denominator. Well, we know that the square root of x plus 4 has to be, or cannot be, 0. So, how do I solve this? I square both sides, get rid of that square root, and I say, okay, x plus 4, 0 squared is 0, cannot equal 0. So x cannot equal negative 4. So, how do we find the intersection of all of this? Well, f is the entire real numbers, okay? G is everything bigger than negative 4, right? And then, what does this restriction do? This restriction, all this restriction says is, well, it can't be negative 4. So if this value right here was negative 4, I'm just going to say my domain can't be negative 4. Okay, that was a little hard to see here. Let's use a different color. Boom. Can't be negative 4. I've X'd that out. So I can be anything bigger than negative 4. That's fine, right? So I'm going to go, my domain is going to go from negative 4 to infinity. Okay? So that's how we can account for the intersection of the two functions, right? When we're combining functions, but then when we're dividing, we have to account for this extra change. So for this one, that would be the answer. All right.